In this video, we're going to be talking about solving an exponential equation by finding common bases with linear exponents. Okay, so by common bases, we're looking at, say, this first problem. The base of this one on the left is a 5, and the base of this one is a 25. So we want to make those try to be the same. And if you can make them the same, so the rule is if you can make the bases the same, like if we have a to the x minus 3 is equal to a to the 2x plus 1. If they have the bases that are the same, then you can just cancel out their bases by technically you'd be applying a logarithm to both sides, and you would get x minus 3 is equal to 2x plus 1. Okay, so you get that exponent, and then you solve for the exponent, and you're solving for the entire thing. All right, so let's take a look at this first one. We've got 5 to the negative 4x equals 25 to the x plus 3. Now, I know that, first of all, these are different bases, but I know that 25 can be written as 5 squared. So I'm going to write it that way, and that will give me 5 to the 4x on the left, and then I have 5 squared to the power of x plus 3. Okay, so we have the same bases, and when you have a power to a power, you simply multiply that. So it would end up being 5 to the 4x is equal to 5 to the 2 times x plus 3. And then we could drop the base, drop the 5. So we'd end up with 4x is equal to this exponent, and I'm going to go ahead and distribute. So it would be 2x and then plus 6. So if we solve this equation, we will get the answer to this equation. Okay, so let's subtract the 2x from both sides. And that will give me 2x is equal to 6. And if I divide the 2 on both sides, I will get x is equal to 3. And that's going to be my solution for this problem. Okay, let's take a look at the next one. So we've got 100 to the 2x plus 4 and 10 to the 2x. So they're not the same base, but I know that 100 can be written as 10 to the 2. 10 squared is 100, and that will give me like bases. Okay, so I will write this one as 10 to the 2, and I'm going to go ahead and just multiply because I know the next step when I have it like this is just multiply. So I'm going to do 2 times 2x plus 4 equals 10 to the 2x. Okay, so instead of having 100 raised to the 2x plus 4, I have 10 squared raised to the 2x plus 4. Now I'll drop those 10s, so that gives me 2 times 2x plus 4 equals 2x. I can distribute to both of these. That will give me 4x plus 8 is equal to 2x. Okay, let's subtract the 4x. And that will give me 8 is equal to negative 2x. And if I divide by the negative 2, that will give me x is equal to negative 4. Okay, let's look at the next one. So this one has a base of 16, and this one has a base of 64. Okay, so 16, let's think 16 to the 2 power is 256, so it's way too big. So we can't use 16 as the base, so we've got to change both of these bases. I do know that 16 is equal to 4 squared, and I do know that 64 is equal to 4 cubed. Okay, so I can use 4 as a base on both of these. So this one over here would be 4 squared to the x plus 1, and this one over here would just be 4 to the 3. Okay, so instead of writing 16, I went 4 squared to the x plus 1, and here it was 4 to the 3rd. I will drop the bases, which will give me 2x plus 2. I went ahead and distributed that, equals 3, the exponent. So I drop these, and I'm just looking at the exponent. Subtract the 2, and I get 2x is equal to 1, and x is equal to 1/2 when I divide 2 on both sides. Okay. Do 3 more examples here. So I've got a 64 and a 2. Okay, 2 can't get much smaller, right? So we're probably not changing this base. We need to write 2 or 64 as a power of 2. Let's see, 2 times 2 is 4. 2 times 2 times 2 is 8. Another 2 would make 16, another 2 would make 64, and one more 2, or 32, and one more 2 would make 64. So it goes 2, 4, 8, 16, 32, 64, and then 128, and then so on. So we know that 2 to the power of 1, 2, 3, 4, 5, 6 is the same as 64. So 2 to the 6 to the 4x minus 4 equals 2 to the 18x. Now we can drop the exponents and go ahead and distribute the bases and go ahead and distribute this. So 6 times 4x is 24x, and 6 times negative 4 is negative 24, equals 18x. Now I can subtract 18x from both sides, and then I can also, well, I'll do that in the next step, 6x minus 24 equals 0. Then I can go ahead and add that 24 over there. So I get 6x equals 24. Divide both sides by 6, and I get x is equal to 4. Okay, let's look at this one. We have a base of 4 and 16. 16 is 4 squared, so I can use that as a base. You could also use 2 as a base if you wanted to. 4 is equal to 2 squared, and 16 is equal to 2 to the 4th. But 4 is easier because it's already, 1 is already in that form. So 16 is 4 squared, so it's going to be 4 to the 2 times 4 minus 3x. Drop the bases and distribute, so you get negative 8x equals 8 minus 6x. Okay, let's go ahead and add the 6x to both sides, and that will give me negative 2x is equal to 8. And if I divide by negative 2, I get x is equal to negative 4. Okay, last one. We've got 9 and 81. We could use 9. 9 is the same thing. 9 squared is the same thing as 81. That would be the easiest way. I'm going to do it a different way this time, just to show that it can be done a different way. I'm going to make them both powers of 3. So I know that 9 is equal to 3 squared, and I know that 81 is equal to 3 to the 4th. Okay, so I can do 3 to the 2 times 6x equals 3 to the 4 times 4x plus 1. Okay, so 3 squared is 9, 3 to the 4th is 81. Okay, now I can drop the bases and distribute. That'll give me 12x is equal to 16x plus 4. Subtract the 16x on both sides, and that gives me negative 4x is equal to 4. And when I divide the negative 4 on both sides, I get my solution of x is equal to negative 1.